Hello, my name is Vlad TEODORESCU. I'm a PhD student in finance at the Bucharest University of Economic Studies, Romania. I will be presenting Predicting Firm Failure in Romania, the role of regional information in XGBoost models. The research questions are: do regional differences matter for firm failure prediction using XGBoost? And also, what is the best way of incorporating regional information into such a model? At what granularity, and should separate regional models be trained and used instead of a single pooled model trained on the whole dataset? Our main findings are: there are important regional differences in economic structure, size, firm failure rates, and difficulty of predicting firm failure between Romania's regions. Regional information improves model firm failure predictive performance, and pooled models trained on the whole economy outperform regional models even when regional information is absent. Part of the regional information is embedded in other explanatory variables. Data. I used the Orbis database and I downloaded all Romanian companies with at least one employee and with positive total equity in 2021 and financial statements reported in 2022. I downloaded over 360,000 companies, individual companies. Since in Orbis there is no direct definition of failure or bankruptcy for Romanian companies, I used the proxy, an accounting proxy for firm failure, that is the transition from positive to negative equity. Such a definition has been used in literature before. So y equals 0, the target variable y equals 0 if equity remains positive in 2022 and it was positive in 2021. The failed firms y equal 1 if equity was positive in 2021 and negative in 2022. We have, like I said, over 360,000 companies with over 16,000 failed firms, representing a failure rate of 4.6%. Regional information at county level is available for all companies except 293, of which only 2 are labeled as failed. The explanatory variables correspond to the year 2021, since we're trying to predict the year 2022. We computed 44 financial ratios in 7 categories: liquidity, solvency, turnover, profitability, interest coverage ratios, productivity, and other. We also used number of employees, NACE codes, which is an industry classification, total assets in levels, which is the total asset reported in company balance sheets, as a measure of, and the only measure of company size, since ratios are relative, and also region at county level. Methodology. We used the XGBoost machine learning model that often achieves superior performance of structured tabular data. It is based on decision trees and it creates an ensemble of decision trees. This ensemble is created sequentially, each new tree being added such that it improves the prediction of the previous ensemble. For validation, we use k-fold cross-validation with k equal 4 stratified over y. The k-fold cross-validation technique entails taking the whole data set, and if k is 4, we divide the data into 4 folds. And then we take aside one fold, say the 4th one, and the remaining 3, 1, 2, and 3, we use them to train a model. So we train the model on 75% of the data, and then we test it out of sample on the 4th fold. And then we iterate, we set aside the 3rd fold for testing, and we train another model on folds 1, 2, and 4. And then again, we set aside the 2nd fold, and we train the model on folds 1, 3, and 4. And lastly, we set aside the fold number 1, and we train the model on 2, 3, and 4. So we obtain 4 models, each of them trained on 75% of the data, and also we obtain out-of-sample predictions for all observations in the dataset, because each observation in the dataset is predicted by a model that has not seen it during training. Permutation feature importance is a measure of variable importance that entails taking, for one variable, that entails taking its values and permuting them between observations. We observe a deterioration in model performance between the original model performance and the model performance with the variable y permuted. If this deterioration or this PFI score is large, it means the model relies on this variable for its performance. It should be noted that the permutations are being done on the test set only. So in the case of k-fold cross-validation, you only permute for the test fold. We use log loss as performance metric because it measures the quality of predictors, not just the ordering or the classification. And also we use log loss because it is additive, and in the context of performance feature importance, it's more meaningful because, again, PFI scores are differences in performance. The log loss is influenced by the underlying failure rate as much as other performance metrics are also influenced by the underlying failure rate, which means that models evaluated on data sets with different failure rates may exhibit different log loss measures even if the models are similar in predictive quality. This is relevant for us because we have 8 regions and each region has a different underlying failure rate, which means that the baseline log loss is different, meaning that models are not directly comparable. So if in a region we observe a lower log loss than in another region, it doesn't mean necessarily that one region's model is better or better able to extract information, or that the companies in said region are easier to separate. In order to draw such conclusions, we need to interpret log loss relative to the Bernoulli entropy, which the Bernoulli entropy is the log loss of the naive model that predicts the observed failure rate for all companies. And we interpret log loss as a percentage of Bernoulli entropy. So a percentage meaning how much information is the model able to extract relative to the baseline. Our experimental design, in order to assess the impact of regional information on firm failure modeling, we trained various models with alternative configurations, without any regional information, with regional information at county level, with regional information at aggregate regional level, so for the 8 regions, and also we trained separate regional models, one on each region, retaining the original information at county level. Results. First, we note that there are significant regional differences for Romania's companies. For example, in terms of total assets, the Bucharest-Ilfov region, which is the capital plus the surrounding county, accounts for more than 40% of the total assets of the economy. Less so in terms of number of companies, which means that companies in Bucharest-Ilfov are actually larger. We also find significant regional differences. So, for example, the services sector and the trade and transportation sector are more represented in the Bucharest-Ilfov region, while the industry sector, it's more represented in the center region. There are significant regional differences in terms of failure rates. So we can see that, for example, the Bucharest region sees the highest failure rate, 5%, while the Northeast region is only registers 3.7%. What is the predictive value of regional information? So we find that regional information moderately improves performance. We can see this. We have a baseline model with regional information at county level, so the most detailed information. And a model with no regional information has a deterioration of performance of minus 0.3%, which is moderate, is statistically significant. If we retain the regional information at aggregate level, then we see almost no deterioration. There is some difference at the fifth digit, but it's not statistically significant. And also we see that separate regional models with regional information retained at county level are actually inferior to pooled models with no regional information. So indeed, pool models outperform separate regional models by a wide margin. There are regional differences in variable class importance. We analyzed the variable importance of on classes of variables because counting variables are overlapping in terms of information, and also a lot of them are correlated. So we find it more relevant to analyze variable importance on classes of variables rather than individual variables. And we see that the most important classes of variables remain the same in all regions, at least the top three. So we have the solvency, total assets in levels, which is a company size, and also profitability. These differences here, they are statistically significant, but they aren't large enough as to affect the ranking of the variable importance. So we might argue, so this is evidence, we might argue that there are some similarities in terms of failure mechanisms and in terms of the way the models are using the information and are relying on similar variables. Conclusions. Our conclusions are that pooled models outperform separate regional models. Also, the regional information moderately improves model performance. Our findings taken together suggest that there are common failure mechanisms across regions and that part of the regional information is also embedded in other explanatory variables. The main limitation of our paper stems from the definition of firm failure. Practitioners in general would prefer to have an external, and in practice would use an external definition of bankruptcy or default, an event that actually happened to the company. We were forced to use an accounting proxy because we didn't have access to a default or bankruptcy. And this limitation might also explain in part why solvency ratios seem to dominate variable importance measures. Thank you very much.